This is the video solution to example number 2 for free body diagrams, and this is the review problems. Alright, so here's a basic problem that you should have already worked on by now. So let's go through the answer. To begin with, here's my strategy. When I look at this, I look at all my givens, I can see that I'm looking for the time. So if I'm looking for the time, that's going to be kinematics. So I'm going to use kinematics to find the time. But if I really list my givens, I can see that I don't have an acceleration. So what I need to do is use the free body diagrams to set up everything to find my acceleration. So I'm going to do this backwards. I'm going to do the free body diagram first, then I'm going to use kinematics to find the time. To begin with, let's start with the free body diagram of box A. So if I look at box A, here's my free body diagram, so it's free of all the details. Notice it's not a box, it's actually just a dot representing the free body diagram. And it's going to have tension going up and mg going down, but not just mg, I'm going to write the weight as m subscript a times g going down. And the box is moving up because box B is heavier than A and there's no friction on the pulley. So B is going to go down and A is going to go up. So that's going to be the net acceleration. The net force is going to go upwards, and that's going to be MA net. I'll sum up the forces in the x direction. Great, I can identify that there's nothing going in the x direction. And then I'll sum up the forces in the y direction. In the y direction, it's MA times A equals T minus MAG. So let's talk about the signs. MA net we're always going to make positive, and that's going upwards. T goes the same direction as MA net. Because it goes the same direction upwards, it's got to have the same sign as MA net. And MG goes the opposite direction of MA net's direction, so it's got to have the opposite sign of MA net, which is where the negative comes from. So this gives us MA subscript, or M subscript A is equal to T minus M subscript G. Notice I'm not putting in numbers, I'm keeping my variables at this point. Okay, let's take a look at box B, another free body diagram. I'll have tension going up, M subscript B times G going down, and box B is going to the ground, so its net force is going to go downwards. So it's MB times A. These A's in these two free body diagrams are the same, but the forces are not because the boxes have different masses. Let's sum up the forces in the x direction. That's going to be equal to 0. In the y direction, that's going to be MA or MB subscript, sorry, M subscript B times A equals M subscript B times G minus tension. Again, let's look at the signs. MA in this case goes downwards. That's the net force. M subscript BG also goes in the same direction, so it'll have the same sign as MA. And tension goes the opposite direction of MA, so it's going to have the opposite sign of MA. That's why it's negative. Okay, let's keep working the problem, and I get MB is equal to MBA is equal to MBG minus tension. Now at this point, from looking at it, I've got A and I've got T, two unknowns and two equations. There are a couple ways to solve it, but if I'm going to use substitution, I'm going to solve one equation for T and put that expression in for T on the other equation. So I'm going to take the equation on the right for box B, and I'm going to solve that for T. Again, there are multiple ways of getting the correct answer. This is just one. So T is equal to MBG minus MBA, and I'll take this whole expression, and I'm going to put it over into box A's expression. So instead of T, I'm going to replace it with my expression of MBG minus MBA. I'll take everything with an A and pull it on one side of the equation, so that's MAA and MBA. And then I'll use the distributive property to pull the A out. So A times the quantity MA plus MB. All right, let's take a look at this, make some room. I'll take that expression and I'll isolate A all by itself, so it's going to give me just this fraction up here. I know G, I know the mass of B and the mass of A, so I'm set. I've got all the numbers for A so I can find it, but don't. I want to use this expression in my equation. So now let's switch gears and look at kinematics, because I've found the acceleration, which was my goal with free body diagrams. Let's switch to kinematics. Start with the givens. I know the initial velocity is 0, A is this equation, which I'll put numbers in later, and x is 1.5, and I'm looking for t. So if I examine all this, I realize I need that expression where x is equal to x naught plus v naught t plus 1/2 at squared. So x is equal to 0 plus 0 plus 1/2 at squared. Therefore, x is equal to 1/2 at squared. So if I rearrange this for t, t is equal to the square root of 2x over a. So t is equal to the square root of 2x divided by that whole fraction that I have up there at the top of the screen in black for a. And then I can rearrange the fraction a little bit to make the math easier. Next step, put in numbers and units. and I get the answer of 0.782 seconds. So it takes 0.782 seconds for box B to fall down and hit the ground 1.5 meters below the starting height.